Okay, so you should be able to see the screen now. And okay, so today's lecture is going to be about a memory, as the title suggests, and obviously it's a kind of continuation from last week, although of course from a slightly different type of memory. And like I said, actually the memory part of this course will cover several lectures. So this is just the second. The others, although they don't sound like it, they actually are about memory. So hold on one second. Okay, so we asked several questions about memory last week, and that kind of helped us and actually anyone who does any research into this kind of thing, craft the type of study that they want to do, right? And also helps to craft a framework for understanding. So the same way, we can ask some questions regarding long-term memory, and we can ask, for example, um, you know, how long does it last, right? I mean, when you say you've got long-term memory, how long is long-term, basically? You can ask another question, which, in other words, what's the duration, right? So that's what we talked about last week. Um, Another a question you can ask is about the capacity, how much can it store? And then, of course, you can ask the final question, which is, is it a singular thing or not? So in other words, is long-term memory just long-term memory? Or are there different sorts? So I'll talk about each of these today. So this lecture will actually be a slightly a longer one. But one nice thing about long-term memory is that I think in many ways it squares reasonably well with the way we think of memory in a kind of a layperson's perspective, right? Or taking a person's perspective. So um, this is the model that we talked about last week, and you've got your sensory register, then followed by a short-term store, and then of course there's a long-term store. Now, one thing about this is, of course, if we know that short-term memory basically stores information that we're getting from the environment. In other words, if you have to learn something, a list, or you see something, or somebody tells you something, and you want to store it, you start off in short-term memory. But at some point, you will want to take whatever's in short-term memory, and then you will want to shunt it into a long-term memory. The reason for this, of course, is that you might want to make the memory more durable, and so and therefore a memory that can be held for a longer period of time. So between the two, one can think of there as being a kind of process where you take something in the short term, and then you basically consolidate it and turn it into something long term. In other words, you turn it into something more durable. And so this process of consolidation, actually, you could probably fill 3/4, if not a whole course on just this. But for today, we'll just talk about some of the basic aspects of this, right? So it's here that's kind of interesting. What do I need to do in order to take something from the short term and put it into the long term? So if we think of it that way, then the question becomes, how do we actually store memories for for the long haul, essentially? How do you turn something into a long-term memory? And one obvious one, which I think most people come up with if you ask them, is rehearsal. So the idea is that if I simply rehearse something often enough, or I try hard enough to rehearse something, and as you can see, rehearsal is a really key part, right? Even in short-term memory, right? I mean, the working memory models have mechanisms for for rehearsing, right? Whatever's inside the storehouses. So one can ask the question, right? Is it basically the case that if you rehearse something enough, that should suffice, and that's the only thing that will uh, that's required, right, to turn something from short term to long term? So this is a study that we saw last week, and I'm sure you can remember it. So this is the primacy effect part. This is the recency effect part, and of course, just quickly run through. Um, you present words in sequence, right? So from 1 to 20. So you start off with a person being presented table, candle, maple, so on. Then you go to letter, turkey, and hammer. So the graph, as you I'm sure remember, basically plots serial position, or excuse me, it actually plots performance as a function of serial position. Again, this is wrong, right? I think this should be percentage. Um, and you find that, of course, words at the beginning of the list people do very well or reasonably well, and then words at the end of the list people do very, very well. And of course, this is because it's still in short-term memory, so it's still current. And this is because people get a chance to rehearse. So what has this got to do with rehearsal and what we were just talking about? So what you see at the bottom is a kind of follow-up study to this, and it looks at the effects of rehearsal. So this is this is correct, right? So its probability, right, goes up to 1.0, and serial position as well. So this would be words at the start of the list, words at the end of the list. Um, and then you notice that there are two y-axes. So this y-axis over here basically is total rehearsals per item. So what they did in this study, or what was done in this study rather, was that participants actually did the experiment as we described it last week. So like this version up here. And then there was another kind of version where you actually ask people to see how many times you rehearse an item. So you count how many times you rehearse an item. And so the solid black line over here that connects the little round circles, this is basically the kind of the graph you get up here, right? It's a U-shaped thing. So you get very good performance at the start of the list, very good performance at the end of the list. But the line that we're interested in today is actually this dashed line here that connects the open triangles. And this line actually has to do with the total number of rehearsals that people see, that people perform per item. Again, as a function of serial position. So this is actually quite an interesting study for two reasons. The first is that it shows you that for the start of the list, you'll notice that the number of rehearsals is very, very high, right? Consistent with the story that we were telling, that if you can rehearse that this part here, this part over here, is because when an item comes in early, you're going to start rehearsing it. And because it's early, you're going to rehearse it more than items later on in the list. So you see there's a very tight coupling of the two over here, right? And then what you find, of course, is that um, number of rehearsals tapers off, right? Or drops off, excuse me. And this is consistent, right? Because if you have more and more items, it's harder and harder to rehearse every single thing. And of course, things that come in later, you're going to rehearse less often than things that come in earlier for obvious reasons. So the second thing that's very interesting here, of course, is that if you look at the recency effect, you will see that it's completely decoupled from the number of rehearsals. So whatever is happening here, the recency effect, and this was the story, excuse me, the story we were talking about last week, is completely, it is not dependent on number of rehearsals at all. So there's no relationship between the two, suggesting that whatever is happening at the front of the list and at the back of the list are different, right? They're based on different mechanisms. So this was a story that we were talking, we were um, describing last week, right? So you find that items here, probably it's because of the number of rehearsals, and as you rehearse more, your performance is better. But whatever is going on at the later part of the list, or for the later part of the list, excuse me, has really nothing to do with rehearsals. And remember what we said. We said that this part of the list over here, obviously, it's already outside of short-term memory, right? So this could be because everything is just fresh. It's still in short-term memory, working memory, I guess you want to put it that way. But this is actually caused by something else, right? The memory has maybe changed a little, probably because of the number of rehearsals. So rehearsals appear to be quite important, and they can help a lot by taking something in the short term and turning it into something slightly more durable. But then the question, of course, comes down to, um, is it the sole factor that is important? And the reality is actually no. There are many other factors that can influence whether something becomes a long-term memory or not, something becomes more durable or not. Um, and I'll talk about some of these for the rest of the course, just to show that there is some complexity to this. So one of the things that um, researchers have suggested, in addition to rehearsal, so rehearsal is actually quite rote, right? You just basically keep repeating it to yourself until such time as it, you know, it takes hold, right? And then it becomes, you know, something that you can remember for a longer period of time. But these other researchers, Craig and Lockhart, suggest something that's uh, quite different, right? So they are suggesting that it's the depth of processing, or sometimes called the levels of processing, but uh, uh, this is something that's quite different from simple rehearsal. The idea here is that the durability of a memory, in other words, whether you can remember it for a long term, for a long period or not, is really dependent on how you encode it, and in particular, the depth of encoding. I guess one way of thinking of this is almost like the quality of the encoding. And so the depth of encoding can actually range from shallow to deep. So in other words, you can have shallow processing of some information, or you can have deep processing of that information. And so it's important to distinguish between shallow and deep, obviously, right? So shallow encoding really refers to processing of surface features, what the thing looks like, what the thing might sound like, you know, shape, color, that kind of thing. Um, and deep processing is different. Deep processing refers to processing a stimulus or some information for its meaning. So in other words, you know what that piece of information that you've been presented with um, means, right? And so the question is, will these two things actually produce different patterns of memory, different memory performance? And to preview actually the findings and the experiment, I'll say that essentially it's the deeper encoding, so the deeper processing, that results in better and longer lasting memory, right? Better and longer lasting than if you encoded the thing using shallow processing. So how do you tell something like this? So in this experiment, basically participants were uh, told to listen to uh, basically word pairs, right? And then they were told to try and remember the words. So in other words, in this case, right, you are being asked to intentionally remember the stimuli. And others were told to focus on very specific. So in other words, some were told to try and remember the words, and that's all they were told. That's the instruction. You just try and remember this. Do whatever you want, but I'm going to test you later, right? And I'm going to test you sometime later, right? So not 18 seconds, much later than that. Others were told to focus on specific aspects of the word. Okay, so two almost like different groups here. So again, just to rehash, right? One group was just told, hey, you just try and remember it, remember this, do whatever you want, right? Just do your usual thing, try and memorize. So the other subjects were told to actually consider if to consider certain aspects of the word. And for example, if you see the word like outcast, right? Some people, so one group will be told, okay, you see the word, you just try and remember. So they'll just do their best to remember outcast. They don't have to do anything other than what they normally do when they try and remember things or memorize things. Another group would be asked to determine for every single word that's presented to them, does it contain a, the letter E? So you just say yes or no. So if you look at this outcast, you say no, right? Then another group might be asked, how many letters are there in each word? So you just count off. That's all they have to do. Um, And then uh, another group might be asked to rate whether the valence of the word or the the whether the word's a positive word or negative word in terms of emotional value, right? So um, if you look at this word outcast, I guess the answer is no, right? It is generally an unpleasant word. It's got a negative connotation to it. So if you look at the examples I've given, does it contain an E? This is basically a surface type processing, right? Because all you're doing is looking out for a specific letter. You don't really care what the word means. I mean, the word, it could be a letter string, may not even, be a real word, right? You could just make something up, and then you could still look for the letter E. You, When you look for the number of letters, same thing, surface thing, you don't have to care what the word actually means. But obviously for this one over here, where you're saying, is this word a pleasant word or not? In other words, you're rating the valence of the thing. Um, then in this case, you do have to know what the word means, right? So the only way to tell that this is a word with a negative connotation is if you've decoded what outcast means, right? You know what outcast means. So these are different versions of this. So what happens when you test memory subsequently for this? So these are the results. The bar on the right is basically when people are told to memorize the thing and they can do whatever they want. So they're trying their best to remember this for a reasonably long period of time because they know they're going to be tested. So this is intentional memorization, and it's kind of like a free and easy kind of thing. You just do whatever you typically do when you're told to remember a list of words. So this is the one where you're asked, is there a letter E? This is number of letters, right? So another, all of this is encoding, right? So when you're shown the word, you're asked, does it contain a letter E, right? And that's during the study phase. So this is memory for words that people made a yes E or no E decision, right? This is when people during the encoding phase, so when they're trying to learn the words or when the words are presented to them for the first time, are asked to just count the number of letters. And then this one over here is when people um, are asked whether the word's a pleasant word or not, right? So in other words, has it got a positive connotation or not? So we can say several things about this, right? First of all, if you look at memorization, the bar that is closest to it is the pleasant one. So and also when you do the surface processing, number of letters versus and does the thing have a letter E or not? You notice that the bars here are much lower, which means memory for these words, right, that have been processed at the surface level, is actually poorer than when people intentionally memorize things. So what does this tell us? It tells us that actually, when people try and memorize things, the chances are that they're going to try and process it for meaning. When you're given a list of words to memorize, it's unlikely you're going to look at just the surface features of those words. It's unlikely that you're actually just doing something like, oh, how many letters does it have? What font is it? Things like that. It's unlikely you do that. And the reason for that is that when you do that type of processing, you find the performance is quite poor, right? Um, and so this suggests something that above and beyond what you would get when you think about things like rehearsal, right? Here, it's not the fact that you rehearse the thing or not. It's really whether or not you process it to a certain level. And if you process it much more deeply, then your memory for that thing for a longer period of time is better. The nice thing, of course, is that you don't have to do a psychology course or cognitive psychology course to know this or do this. What you see over here looks like people are already doing this on their own, right? You don't have to know about deep versus shallow processing. When people are told to remember things and they're told, look, I'm going to test you sometime down the line, they will try and access the meaning of the words, right? And that's why performance, when you in an unconstrained intentional memorization condition like this one over here, is more or less the same as when people are told to do deep processing. People do not, when they're given this kind of scenario, do shallow processing. Okay, so then one might say, well, okay, we've got two things now. We've got rehearsal and we've got depth of processing. So then the thing is, well, the depth of processing thing looks pretty convincing, right? Especially since it doesn't require any special knowledge. People seem to be doing that on their own. So then you might ask, well, is depth of processing then the only thing that determines whether we can remember things for the long term or not? I guess, of course, rehearsal is another. But it appears that the context in which you learn something, and also when you try and remember something, appears to be quite important. So I'm going to spend some time talking about this because the idea of context can be quite different, right? And you can find that there are contextual differences, and these take various forms. So they're not obvious, right? And I'll show how these different things actually might contribute to better long-term memory performance. So this one's something called encoding specificity. And the idea here is that recall is better if the retrieval context is like the encoding context. In other words, if there's so the retrieval context would be the test phase, right? It's when you're tested. And the encoding context is the study phase, when you're first presented with the items to study or to learn, right? The idea is that if there's a match between these two, then it's good and it's going to help you with your memory performance. So this is a study that was done by Tulving and Osler. Endel Tulving is actually a very famous um, memory researcher, right? So it's one of those names you might want to remember. In this study, right, the participants basically learn list of words, right? And they learn the words under primarily two encoding conditions. So they learn the word either as a single word. In other words, you're presented with the word health, and that's all you have to remember. That's all you're given, and you're told to remember the word health, right? For subsequent testing. Then there's something called the cued study condition or cued encoding. And so you see, if you look, in this kind of thing, it's very simple. You could tell the participants to actually just remember the word in uppercase, for example. Anything that's not uppercase, you don't have to remember. But in this one, so the word they're supposed to remember is the word eagle. But you'll notice that it's presented together with another word, soar. And the two of them, to be honest, they're related, right? Because eagles fly, or they can be described as soaring through the air, right? So this is a word that's somewhat is related to the word that's to be to be remembered, right? But they're told this is irrelevant. You don't have to do anything with it. I mean, it's neither there. It's not for you to remember. But if you happen to remember it, it actually might help you with your memory for the target item. So this is the word that people need to remember. This one, they're told, well, I'm going to present it. It might be helpful if you remembered it because it's related, but it's not something that you should try and remember in and of itself. Okay. So this study basically then produced these different conditions. So these are the four. These are the two conditions, right? Single and cued, but they are crossed with during the test phase whether or not you have a single or cued condition there as well. So what happens in a single, right? So single encoding and single retrieval. People are just presented with this word over here, and then during the test, they just said, okay, just tell me everything that you were shown. So you just recall the thing that you were presented with earlier. Then you can have a scenario where you have a single word at study. So you just presented the word eagle, but during the retrieval phase, you're actually presented with the cue, right? With a cue, right? So like saw. Now, of course, this word is related to eagle, so on its own, maybe it's helpful, right? So you see the word saw, you might think, oh, okay, well, I'll just think of things that saw. Maybe it's a trigger for retrieval of the correct of the item I was told to study. Then you've got one where you're cued and you're studying it in a cute way, so saw an eagle, but at the test phase, you're just told recall whatever was the word in uppercase, right? So you just asked to produce the target word, which is eagle. Then of course you've got cued and then cued test phase, right? So you're shown saw and um, eagle, and then you're presented saw, and you're supposed to output eagle, right? So if you look at this scenario, it's basically just crossing 2 by 2, right? So if you look at this, you might think that, and you can ask yourself, which one do you think is going to produce the best performance? So I think if people try and answer this intuitively, they'll probably say because the cue word is always related to the target word, that performance will always be better when there is a, a cue presented during the study phase, right? Whether or not it was presented in the a cue was presented in the test phase, whether or not the cue was presented in the study phase. So in other words, whenever I present the cue, performance should be best. It's intuitive, right? Because the thing, after all, is related to the word that's going to be that you are asked to remember anyway. So it's almost like being given a hint, right? Even though the hint wasn't given to you during the study phase, if it's given to you during the test, that should suffice, right? You should always do better. But in fact, what happens is that performance is best for these two conditions in blue, the cued, and the single. Now the cued, I think that one's maybe pretty obvious, and it's hard to say why. I mean, of course, maybe it's because there's a cue, and maybe you remember the cues from the study phase, so maybe that's why it's so good. But the question is, why is a single so good, right? In particular, why is the single encoding, single retrieval condition better than single cued? This one here, right? Because here there is actually a hint, there's a clue. So why is it that the cue doesn't help? And I think the reason here is because the thing that's much more important in determining memory performance in this kind of setup is not so much that there's some cue information or a clue that's being given, but the fact that the test phase matches the encoding phase. And that's why your single, the context is the same. And that's why, and this is the thing that drives the better memory, more so than if there is, a hint that's given, right? For example, in this condition over here. So the match between the encoding and the retrieval context is actually quite important, and it is, at least in this scenario, in this study, actually more important and more helpful than simply presenting, some useful information or some related information that can act like a clue, right? In this case, in the cued test phase condition. Okay, so this one is again kind of similar, and just to show that the different ways of testing this. So in this study, words are presented visually. So in other words, they're presented, you can think of it as presented on a computer screen or on cards or whatever. They're presented visually to participants, okay? And then they were told, and the participants were told, well, I show you the word, right? But you are told to imagine these words as being read out by either a male voice for some participants or a female voice by other participants, okay? So they see the word, but when they read it out to themselves in their head, they need to imagine this as either being read out by a male voice or a female voice. Okay. Now, during the test, the words were presented and all the participants were read out. And the participants simply had to say, yes, this was a word that was shown to me just now, visually, right? Or not. So they make what are called old new judgments. You say old if the word was something you saw earlier in the study phase, and you say new if the word was not presented in the study phase, right? So one of them is the ability to tell things that you have that were presented to you earlier, and then the new judgments are basically you are able to discern those items which were not, right? But by the way, both of these things can actually help point to memory, by the way, right? If you have good memory for something, then you know what was shown to you, but you will also know what was not shown to you, right? So, old and new judgments actually kind of work together. So we'll just look at the bottom one. Of course, there's a condition where you kind of read it out to yourself in your own voice, and that's just your control. But we'll just look at the bottom two lines over here. The solid line connecting the two filled circles, and then the line connecting the two open circles. And so what you find is that this is a crossover interaction, right? Sometimes called a disordinal interaction. But what it suggests is this: if you imagine during the study phase, if you imagined um, the words being read out by a male voice, so in other words, you at study phase, you imagine a male voice, and the test stimuli are presented in a male voice, your performance is good, right? But if you so following on the same line, if you during study phase imagine the words being read out in a male voice, but during the test phase, um, the word is actually read out by in a female voice, you find that performance is poor. And then you see the flip for if you imagined it during the study phase as being read out by a female voice. So what's going on here? Again, same thing, right? Same logic. And actually, this will be the same standard finding you see across all the things I'm going to be talking about in the next few slides. If there is a match between study, like this one over here, and test, performance is very good. Same here, right? If you imagined it in a female voice and it was presented in a female voice, you find that performance is good, right? Better than if it was not. So again, what this points to is that when there is a match between the encoding context, in other words, during the study phase, and the retrieval context, i.e. the test phase, then you find that memory performance is much better than if there wasn't this match. In other words, suggesting that context actually matters. Okay, maybe I'll do one more slide, then we can take a short break. So we talked about in the previous thing, the way the information is presented, and in some cases, it can even the study phase could even be something that happens in your imagination, right? So this one is you're asked to imagine the voices as either being the words as being read out by a male or female voices, right? But during the study phase, by the way, remember this one here is presented to you visually. So during the study phase, nobody is reading anything out to you. You're just told to imagine the words that are shown to you on the screen as being read out by either a male or female voice, right? So the question then is, these are all being done in the mind, even with the cued and single and cued thing, is basically something that happens almost internally, right? You might relate the cue to the target word and things like that. So this one just a little bit of a digression, and this one's a, I guess, very famous study, but it shows that actually the physical context that you are in also plays a role in whether or not you get you show good long-term memory performance. So this study done by Gordon and Baddeley is the same Baddeley from last week, by the way. Actually used or took deep sea divers as participants, right? So these are people who are trained to go diving in the sea. So they're quite comfortable in a aquatic environment, shall we say. And they were told to memorize lists of words, standard kind of thing. You just memorize the list. They're given a list of words and you're told to memorize them. But then they were given this list of words either when they were on a boat, i.e. practically on dry land, or underwater. So that's the unique thing, right? You're given this list of words to remember, and in one case, right, you're being given this word list underwater. And then obviously, a very simple experiment in terms of like the design. These participants were either tested on a boat or underwater, or I guess you could call it on dry land or underwater, right? So these are the results. Same standard pattern, right? So y-axis is of course performance. Higher is better, right? So the more you can remember, and then the x-axis basically is whether is the recall environment. So in other words, whether you are tested on dry land or you are tested underwater. And so what you find is this: if you so we look at the okay, we can ask the intuition, right? The intuitive answer here. If you look at something like this, you would expect that, this is a kind of cognitive test and so on. You might think, well, actually people should be perfect. It should be much better on land. When you're tested on land, there are no distractions and things like that, right? You don't have to worry about breathing, and floating underwater and stuff like that. But that's not what you find, right? So it's not that when you test people on land, performance is always the best. It's not. So it turns out that if you test people on land and they studied the words on land, they're very good. But if they if you test people on land but they learn the words underwater, then you find performance is not so good, right? It is poorer, much poorer. And the interesting thing, of course, is the flip side. If you test people underwater, you might think, well, this should always be at a disadvantage. Actually, it turns out it's not true. It's a disadvantage if you learn the words on land, right? But if you were shown the word list underwater and you're tested underwater, this one over here, then you find that performance is pretty good, right? So in other words, right, the retrieval context and the match with the encoding context, um, it can even be physical, right? It can even be the case of where you studied the thing um, and where you're tested. If these are the same, then you are probably good to go. You're going to find that memory performance is much better than if you were tested anywhere else, right? So the idea of there being a match between retrieval context and encoding context is quite important. In addition to things like depth of processing and of course very basic rehearsal, right? In determining whether you get good performance or not. Okay, I'm going to stop here for a break. Should we just take a short uh, 5-minute break and then we'll come back and talk about we'll continue with the lecture after that. Okay, so see you in 5 minutes.
Attention please, the train approaching platform B will take service at Dotun Point. The train approaching platform B will take service at Next station, Junos. Junos. Junos.
Okay, let's continue. So, um, like I said, this is quite a famous experiment, but there are also other things, of course, that might be interesting to look at. So I'll end off with this one thing when you talk about with respect to context, and that's something called mood-dependent memory. So this is essentially when your mood at study and your mood at test, right, are the same. So as you can see from this graph here, same thing, always a crossover interaction when you got this kind of study. X-axis is the recall, the mood that during the test phase, right? And then the y-axis is of course performance, higher is better, certainly. It's called retention, but that's basically the same as showing that your standard memory performance, right? Whether you can remember or not. Then if you look at the lines, basically it's when you learn the information when you're sad versus when you learn the information when you're happy. And
Next station,
basically what you can see from this graph, I won't go through the mechanics again because we've done several examples of crossover interactions of this sort. The point is, if you learn something when you might think, you can start off again and saying, is this intuitive or counterintuitive? So you might think to yourself, actually, if I do anything um uh when I'm happy, I should be um I should do much better, right? Um, but the truth is that this is not the case. The advantage is when you learn something when you're happy and you are tested in a happy state, right? If you learn something when you're happy, but you're sad, performance is very poor. Then you might think to yourself, well, okay, how about this? If I learn something when I'm sad, chances are I'm not going to be very good at remembering it. But it turns out that's also not true.
Kembangan.
If you learn something you're sad, and you're sad when you recall the thing, performance is pretty good, right? If you learn something when you're sad, but you're tested when you're happy, then it's not very good. So actually, again, this is like context, right? And you notice it's not physical, it's not about any kind of cognitive strategy. So it's not like single versus skewed, that kind of thing. This is really about affect, right? So the affective state that you're in at that particular point. And oh, by the way, it's important to maybe distinguish this, right, from you might have heard of studies where people say you're happy and then you study happy material, right? Is that going to be better than if you're happy and you study sad material, right? This is not that, right? This is the case of this is the state you're in. You're happy at the test at the study phase, and you're happy at the test phase, right? That's the matching that we're talking about here. So again, evidence that this context that we're talking about, it's not tied to anything specific. It's not just physical. It's not just cognitive in terms of the type of strategy that you're using and things like that. So then you might ask yourself, look, so many examples of this. The question is, why is context important? First of all, the idea of context is very broad. That's why so many examples, right? That they actually, context is a kind of, um, is a broad category here. It covers many types of contexts. And so the question is, why is it important? Why is it so good at helping performance, right? Especially long-term memory performance. I suspect the answer to this is that the context itself provides a cue for retrieval, right? Because there is related information, so it's helpful, right? And it's something that you may have taken on board at the point of study. And so when you re-experience the context, what happens is that you are able to use these contextual cues to actually help you retrieve memories, even when these are not maybe not as strong as you would like, but the retrieval cue can be quite helpful here, right? So it's an addition, right? You add to the thing, and in both cases, it's the same context. So you can use it as a hook to actually retrieve memories. And so context, together with rehearsal, together with depth of processing, also appears to be very, very important. There's one. This one's kind of another factor that might be quite useful in helping enhance memory performance. But this one, of course, is based on the specific setup, and this is the thing I'm thinking of here is called distinctiveness. And in particular, it's worthwhile considering the von Restorff effect. So I can't remember if nowadays, during 1101, during your tutorials, whether or not you're shown this. Uh, I sus I suspect it might still be there, right? It's one of the demos. But basically, if you present people with things like this to remember, and then there's this one over here, the rabbit, quite apt, right? Given it's the rabbit year, um, you notice it looks different from the others because these are all very, very light, and this one's quite dark. But other than that, there's nothing special about it, right? I mean, it's not the most complicated picture. This one's much more complicated. It's not the only animal. There are other animals there, and so on. But you find that when you present things like that and you make something distinctive, memory for the distinctive item is much better than for the standard items, right? Again, this could be because the distinctiveness actually adds a kind of cue for retrieval. So many things actually can influence long-term memory performance. Um, Now, of course, you might say, well, what type of distinctiveness? And then it could be basically anything. It could be physical like this. It could be some kind of emotional thing. Could be the type of processing you do and so on. Again, like context, right? It spans many different types of things, right? Um, so I won't go into all of these things, right? Just to point this one out, that actually distinctiveness is also another factor that seems to make memory performance better. Okay, so there's this other thing we talked about, encoding specificity. And you go into the textbook, you hear about something called transfer appropriate processing. So please read up uh, on this on your own. One thing you might want to do is to make sure that you can tell the difference, tell the two apart, right? Encoding specificity and transfer appropriate processing, right? These two things are not the same. You should probably know what they are, but you should also probably know um, why they are different or how they are different, right? So just some homework for you to do, right? Um, okay, so we know long-term memories can last for a long time, right? I mean, as the name suggests, we were talking about this last week, can probably last decades, maybe even your whole life. And they appear, and whether or not something is held for that long appears to be dependent on several different factors. Whether you can rehearse the thing at the start of, when you're, if you have an opportunity to rehearse the thing, that's of course great. If you process it deeply, that's also very good. And then of course, if you've got contextual information that can help you, then that's even better, right? So there are lots of factors that actually influence long-term memory. They can help with consolidating something from the short term into something that is more durable. So we've been talking about this almost like long-term memory is a singular thing, right? There's only one thing that that long-term memory is a single entity, right? But the truth is that actually long-term memory of the sort that we've just been talking about is only one facet of it, and it's the sort that's declarative in nature. It's the sort of thing that you can actually declare. So you learn memory lists, you learn words, pictures, whatever the case may be, right? And the test phase is actually very clear. You're asked to declare what you can remember. Now, you can declare this in several ways. One way is, of course, by recall. So you just say everything that you can remember, and and that's it, right? Another is recognition. So it's like the old new judgments. I present you the word, you tell me, is this something you've seen before or not? Yes or no, right? Old or new. So there are lots of different ways of testing it, but in all cases, the sort that we've just described, it's declarative in nature. But of course, the long-term memory can be um, fractionated into a lot more different subcategories. So the thing, we saw a brain pictures here and all that. I think just to show you, how cognition actually is related to the brain. But the key distinction here is between declarative memory and non-declarative memory. And the fact that, so this picture basically points to the fact that there is this distinction, and that um, in addition to this distinction on conceptual processing grounds, there's also a distinction in terms of the biology, right? So different parts of the brain support the different types of long-term memory. So I think our main focus today will be on the distinction between these two, and I'll just give you some examples of these different types of memories and how these might be tested. So focus on this bit over here, episodic versus semantic memory, and then on procedural memory and something like priming. I won't talk so much about conditioning, right? So declarative memory, this part over here, is the sort that we've been talking about um, all this while, right? And basically, it is memory that we can volitionally articulate, right? So these are things that we have learned that if you ask us, we can tell you remember. Phone numbers, dates, facts, all this sort of thing, right? That, and you can ask people and they'll tell you. Now, is that it? Do these all fall in the same, broad storehouse, if you want to put it that way? And the answer is no, right? So declarative memories can be further fractionated. So you go back to this picture over here. It can be split into episodic memory and semantic memory. So episodic memory, on the one hand, refers to memories for specific events that you have experienced. So this is the kind of thing that most people think of when they think about memory, right? I remember what I did for my last birthday. I remember what I did during the holidays. I remember, what I had for breakfast, should we say, right? Um, and then, of course, this can be contrasted with semantic memory. So semantic memory is basically memory for general information, general facts about the world, right? So if you know that, um, 2 times 2 equals to 4, that's part of semantic memory. If you know what a cat is, that's part of semantic memory, right? So it's basically where you store, your general information, general knowledge, if you want to put it that way. Um, Typically, it's described as like facts about the world, right? And as you can see, these two cover basically most of the types of long-term memories that we have. Um, Oops, sorry. I'll just add one extra thing. So if these are fractionated in this way, then it's possible, for example, to lose episodic memories or to lose the ability to retrieve episodic memories. For example, people who've got amnesia have difficulty with episodic memories, right? But it's also possible to have your episodes intact, but then you start to lose semantic memory, right? So different parts of the brain actually are related to these two types of memories. And if you get damage to one, you might suffer from, either amnesia, uh, if, for example, you damage the hippocampus or medial temporal lobe, right, you get something like amnesia affecting episodic memory. And if you, get damage to a different part of the brain, the frontotemporal pole, right, then you get something called semantic dementia, which is when your semantic memories are affected. But I think this reinforces the idea that these two things are not the same, and they're supported by fundamentally different processes. And these fundamentally different processes are supported by fundamentally different brain regions or different parts of the brain, right? So there's a distinction between these. Not only are these conceptual distinctions, but they're also, in some cases, physical distinctions. But for the purposes of this course, you need to know the difference between episodic memories and semantic memory, right? So going back to this picture over here, so this is this part, right? And there is a distinction between declarative memory and non-declarative memory. So non-declarative memories are the sorts that people can't declare, but these are long-term enduring memories. And a good example of these are procedural memories. So these are basically memories of procedures, right, that you've learned For example, riding a bicycle, right? You get on a bicycle and, once you start pedaling, I mean, if you know how to ride a bicycle, right? Then basically you have no difficulty doing it. The process just engages, right? And you don't have to monitor it. The thing though is that, so of course, before you learn how to ride a bicycle, and after you've learned how to do this, there's a big difference. There's a big change, right? Um, you have introduced this memory of this procedure, right? How to ride a bicycle, how to sign your name, right? Things like that. Um, and so you've learned it. So clearly, therefore, if you've learned it and you can test it, easy to test, right? If you've learned it, you can do it, right? If you've learned how to ride a bicycle, when I give you a bicycle, you get on it, you can ride it without falling down. Um, but you may have difficulty describing this memory. So how describing how you ride a bicycle, how you shift your weight subtly in order to make a turn, right? And things like that. So the memory is basically is there for the long term, but you have difficulty um, articulating the memory itself. So therefore, if it's not about if it's not about how easily you can declare something, how do you test this then, right? So like I said, it's actually very simple. If you have a memory, uh, a procedural memory, a memory for a procedure, right? Then before you learn it and after you learn it, there's going to be a big difference. Before you learn it, you won't be able to do it. After you learn it, you can. Now, of course, one might say, okay, so this is it's almost like binary, but you can actually look at it in a more gradual way. So this is an example of that very famous type of uh, uh, procedural memory test. It's called the mirror drawing test, and it goes like this. So the participant is given a sheet of paper, and on the paper is a shape. So in this case, it's a star, right? And all the participant has to do is he has to trace the outline of the star, right? And without crossing the lines of the um the picture that's on the paper. So you just need to trace the outline, but don't cut into the star or anything like that. Now, this is probably pretty easy to do. So to make this difficult and one where you actually have to learn a procedure, um, what happens is that this is something an occluder is placed in front of the person, right? So he can't directly see the image that he's trying to trace the outline of. And the only way he can see the image is via a mirror that's placed in front of him. So everything is uh, inverted, right? I mean, you're doing this using a mirror image. So what you do with your hand um, is not what you're going to be seeing, right? So this is quite difficult, and you find that people make a lot of errors. So this is how you test whether people have learned to do this properly or not. But by the way, you can do different shapes, right? Because it's not tracing the shape of a star. It's the shape. It's learning how to coordinate your hand in relation to a mirror image, right? So the x-axis is basically trials. So and this is broken down by day. So for day one, they do 10 trials. Day two, that 10 trials. Day three, 10 trials, right? And then the y-axis is basically errors. So obviously, if it's errors, then the higher up, the worse your performance is because it means that there are more errors that you make. So if you look at day one, you see that actually for the earliest trials, performance is very poor because people are making a lot of errors, right? But as time goes on, you find that as people get more and more experience with this procedure, the number of errors actually starts to drop. Then in day two, you get much better performance overall, but it still starts pretty high and then it starts to drop, right? By the end of the training session. And then by day three, performance is negligible. Sorry, the number of errors is negligible. So in other words, the procedure has been learned pretty well. And you test it on day 4, day 10, day 20, whatever, you find that performance is still going to be very, very good because people have learned this procedure already. So this is called the practice effect. In other words, performance increases with the amount of experience you have with the procedure. So the more chance you have to practice the thing, the better you will be because the procedure is reinforced, and then essentially after a while you can execute the procedure, flawlessly and without thinking. Now, when you reach a point like this, so at this point over here, when you ask people day one when they're doing this, they'll be able to tell you all the things that they find difficult. Oh, I can't coordinate my hand movements with the with the mirror image and things like that. And they'll be able to say all the things that they find difficulty, they have difficulty with. Excuse me. Um, but by the time the procedure is completely consolidated and the procedure is now a part of long-term memory, at that point, when you ask people how they're doing it, this is the part where they find difficulty describing it. They don't know how they are coordinating their hand with the mirror image. Um, they don't find it difficult anymore, so they don't say, "Oh, these are all the difficult things that all the difficulties I'm having," and things like that. And this is where the divergence actually occurs, right? So when you've got fully consolidated procedural memory, you find that people have difficulty articulating that memory. The flip is true for declarative memories. When a memory is fully consolidated, it's in long-term memory, or it's at least in the process of being consolidated in long-term memory, you find that people can declare. So one of them is when the memory is quite strong. You can voluntarily articulate it. In the other procedural memory, in this case, you find that people can't articulate it. So that's a second type of that's the other type of long-term memory, and we talked about procedural memories. This is a nice way of thinking about this. It's almost like a skill. Sometimes it's a habit, right? So you see something, immediately do it, right? Because it's a procedure has already been created for that. So we'll talk about priming now. This one's quite a famous one, so it's worthwhile knowing it quite well. So if you think about priming, you can think of that as a distinction between two types of things, because the material can be the same, right? You can have explicit memory and versus implicit memory. And of course, if you want to test explicit memory, then you use an explicit measure. If you want to test implicit memory, then you use an implicit measure. So if you're talking about explicit measures, this is basically all the stuff that we talked about in the first half of this lecture. I give you a list, then you tell me what you can remember. It's explicit. I tell you beforehand, this is a memory test, and then you give the memory test later on, right? So you say, I want you to remember all these things because I'm going to test you later. And then you actually do it. So it's an explicit measure because everything's explicit. You know it's a memory test, you know what the stimuli are, and so on. You can have another way of testing long-term memory, and that is using implicit measures. So basically, with this, what happens is that you tell a participant to perform a task. And then you see, right, whether or not experience with, you ask participants, you expose participants to certain stimuli, and then you see whether exposure to the stimuli actually affects some other type of non-memory task. So in other words, in this case, you don't basically, you don't have to tell people it's a memory test. You expose people to stimuli, you ask them to do something, and then later on, you assess whether experience with that with the stimuli actually affects some other type of task. And this task doesn't have to be a memory-based thing. It can be something else, as you're going to see in the next few slides. So one famous, probably the most famous example of an implicit memory is priming. So what you do is you show participants a list of words, right? And you don't tell them it's a memory test. This is very, very important. If you tell them it's a memory test, then it becomes an explicit measure. And therefore, you're testing explicit memory. So you show them a list of words, ask them to do something to it. I mean, you just don't tell them it's a memory test. You just show them the words, tell them to look at the words one at a time or whatever, right? And then subsequently, you can ask them to do another type of task. And the one I'm going to talk about here is something called a word fragment completion task. Probably because this is the most complicated sounding of the sort, so I thought it might be a good way to introduce this. So what happens is this. Let's say I show you the word kitchen during the study phase. Now you're not told to remember kitchen. You just, you're shown the word I mean, maybe they just flash it to you very quickly or something like that. And this is during the study phase. So you see the word like this. Notice how it's in lowercase, by the way. Then during the test phase, what happens is you're presented with word fragments and you're asked to complete the word fragment with an actual word, hence the name of the task, right? A word fragment completion task. So it is, you're presented with something like this, or you're presented with something like this, right? So the issue here is, of course, how do you fill this fragment in? If you fill it with a kitchen, then of course, it shows that being exposed to kitchen has influenced performance of this task, even though it doesn't sound like a memory task. And so you can test it like this. So you can have a fragment like this, and this is something called repetition priming, because the fragment can be completed by an exact repetition of the word that was in the study. You can have a different version of priming, which is something called semantic priming. We'll talk more about this, I guess, in a later lecture. But suppose you're given a fragment like this, right? And you're shown the word kitchen. So if you uh, complete this, or this word fragment with something that's related to kitchen, for example, like plate, so you fill L here and T here, um, then versus something like filling in with piece, P-A-C-E, right? Um, then actually it suggests that this has had some influence, right? Because if you think about kitchen, immediately you're thinking about all the things in the kitchen. So if you fill this in with the word plate, then it's probably to a higher at a higher probability than say something like piece. Then it's probably because there's a relationship between this and this, and it's because you actually took this on board, right? Then it's actually been entered into memory, and therefore things that are related to it might be much more available to you during this when you're doing this test. So there are lots of ways you can test this. For example, how quickly you can fill the thing in. The likelihood is this is the second one, which is probably the most useful. The likelihood of using something previously seen, i.e., a kitchen, as opposed to other words. So if you fill it in with something else, some other word, even though the word is correct, it actually fills in all the blanks. It's a real word. Um, that just means you filled in the word fragment, right? But it doesn't tell you about memory. So the one which is interesting is that if you fill in the word fragment with the word that you saw previously, or something that's related, right? Like in the second case. Um, Now notice that in this thing, and this is why I was talking about this, I mentioned this slightly earlier. Um, it's important to distinguish between explicit measures and implicit measures, because you notice the stimuli are the same during the study phase. If I were going to use a declarative memory test, I could use words, right? And I could give you a list of words and show them to you. In the implicit measure, you notice in this example, we're also using words. So the difference, of course, is that for an explicit measure, you're testing explicit memory, explicit declarative memory, then basically you're saying, okay, this is a memory test. Here are some things to remember. I'm going to test you on them later. For the implicit measures, where you're measuring implicit memory, you present people with words. You don't tell them it's a memory test. And then you notice the test phase itself doesn't sound like a memory test. You just fill this in with whatever word comes to mind. You're not told fill this in with something you saw earlier. You just told fill this in with whatever comes to mind. And then on the experimenter's end, the experimenter will say, okay, this person has filled this in. Um, did they fill it in with a word they saw earlier or not? Yes or no? Or in this case, did they fill it in with a word that is related to something they saw earlier or not? So the participant doesn't know this is a memory test. And that's the difference between implicit and explicit memory, right? So because the stimuli can be the same and all that, one might say, okay, look, we really need to establish whether there is a difference between implicit and explicit measures, implicit and explicit memory, right? Of course, the measures sound different. So Tulving and Schechter and Stark, actually all very famous researchers in memory, um, did this experiment. So participants were shown 96 words. Okay, so a whole bunch. Actually, the actual number is not really important, but they were shown quite a lot of words, and then they were tested with both explicit and implicit measures. So basically, they kind of split up the list, and some were explicit, some were implicit, right? And then there were two retention intervals. So this one's kind of important: 1 hour and versus 7 days, right? So they're tested twice. whether or not they were told to do the explicit one or the implicit one, they were tested once after 1 hour, and another after 7 days. Of course, 1 hour is a lot more than 18 to 30 seconds, which is the limit of short-term memory. And the number of words is so large that it's unlikely they're going to be rehearsing everything in their head right throughout the whole 1 hour period. So this would be a test of long-term memory, but how long the memories how strong they are after these different intervals. So this is what you get from this study. And um, y-axis is memory performance, so probability of the correct response, so this higher is better. Then the x-axis is basically a retention interval, so 1 hour, 7 days, as I was saying. So the bars or the lines actually are when people were given the explicit task, so you do a recognition test. And then the other one is you do fragment completion. It's exactly the same thing that we were describing just now. The first thing that you will notice is that the patterns for the two are quite different. So for the recognition, this one here, you'll see that performance drops dramatically after 7 days. This is not shocking. All right. If I give you a test immediately after this, or 1 hour after this lecture is over, probably everyone will do quite well. If I test the facts after 7 days and people haven't really been like rehearsing it or whatever, then performance is going to drop. So it's nothing strange here. But if you look at the fragment completion line, which is the implicit memory test, you will see that performance is flat, right? It is no there's after 7 days is as good as after 1 hour. So the point here is that the two types of memories are different. They have different profiles, right? Performance profiles. And implicit memories, right? Even though you're not really trying to do things, maybe after 1 hour, of course, if performance for recognition is better, but then this drops off dramatically. But here it's stable over time. So what you're seeing basically is that there is a distinction between explicit and implicit memories in terms of performance. They're not exactly the same because probably they're going to be subject to fundamentally different processes. If I'm trying to remember something, I can use all the conscious memorization techniques that I have available right to me. But if it's implicit, I don't know it's a memory test. I can't do this. So the memory just goes in there and then it stays, right? And I'm not testing it using the regular kind of memory test way in any case, right? So there's a difference between uh, implicit and explicit measures in terms of the behavior performance, right? And also in terms of as a function of testing interval, shall we say, right? So this one's maybe a little bit more obvious, but it's worthwhile mentioning because we started talking a little bit about the brain earlier. So this one is to point out that, when you've got amnesia, as I was saying, you have explicit memory problems. Declarative memories are affected. That's the hallmark of amnesia. You can't learn new things, in a kind of explicit way. And then some of your old episodic memories may be lost as well. Not all, but some. Um, and so in this study, basically, we're looking at um, a study by Warrington and Weisskranz, uh, also pretty famous researchers, right? And so in this case, it's kind of like priming, but not exactly. So in this experiment, what happens is that participants were shown words were degraded like this, and then they were told to guess what the words were. Now, some of the words, the degraded words, were words that had been seen before. In other words, they were shown during a study phase. And others, right, they were, of course, new words that had not been shown during the study phase. So the question, of course, is, are people going to recognize the degraded words better if they were shown before or not? And you notice how this is kind of analogous to the word stem or word fragment completion task, which we talked about earlier. So different ways of calling it, right? But basically, you've got a word stem is basically, or a word fragment is basically a word that's been degraded because you've taken away some letters. Here, you might obscure certain letters, and then you see how quickly people can actually respond to the task. Whether how accurately they can respond and whether or not they can guess the word and how quickly they can do it, right? So you can have two groups of people who've got amnesia and people who don't. And what you find is that for If you give people a task, amnesics a task where you have to, in an explicit memory task, I give you a list of words, then later on I tell you to remember them or recall them, amnesics always do poorly because that is the nature of their condition, right? So they will always do worse than normal controls. But for a task like this, which is implicit in nature, because you're not told to remember anything, I show you some words, you just look at them, and later on I give you something like this, you find that amnesic performance is essentially identical to that of normal controls. In other words, for implicit memories, amnesia doesn't really have much impact, right? Amnesia affects explicit memories. But for implicit memories, for things like priming and so on, by the way, even things like procedural memories, the learning a new procedure, amnesics are perfectly fine. It's just the declarative part, the explicit declarative part, which they struggle with. Um, so uh, that is kind of the end of the substantive thing. And it's always, I guess, kind of nice to go back and to this picture over here, right? And it can be very useful in telling the distinctions between the different types of memories, long-term memories, right? Um, so obviously, if just to point this out, if procedural memories and priming are not influenced by the same structures as declarative memories, then if I get amnesia, which is basically a deficit of declarative memory, these two should be spared, right? So fundamentally different memory systems involved. Okay, so that's the end of the substantive part. I'll just give you one other thing for as homework. I mean, if you want to put it that way. So we've talked a lot about how people remember things and the factors that make people better during a memory test. So basically the front half of this lecture. Um, so I would ask you to, on your own, think about forgetting. So what is forgetting? And then, how should you conceptualize this in relation to all the things that we just talked about? I mean, the hint is, of course, that one might just think of it as a complete flip side of it, right? So whatever produces good memory, right? If I don't have those things, then it appears as though I've forgotten, right? So, but it's important to conceptualize this put this into a framework for yourself. It's not difficult, right? Like I said, it's just a flip of all the things we talked about, but it's important to at least go through this and then think about how to, how to really relate these to each other. Okay. So as usual, I'm going to take some questions, but before I do, and before any of you run off, I want to talk about the test and to give you some instructions. I'll put this up on Canvas as well, but I'll talk about them now. Talk about these issues now. So for the test, here's the info. It's on Monday, same time, right? Right now, like this period, right? It's a physical test, so it's going to be held in LT8. So if you don't know where this is, maybe it's a good idea to go and walk around and take a look. It's a big LT, so not too difficult to find. I believe it's underneath the English department, if I'm not wrong. But please go and take a look before the test starts somewhere, right? The type of test is going to be MCQ, just 30 questions, and it's going to be closed book, obviously, right? MCQ. And you'll have 45 minutes to do this. So it's a very simple test, it's not going to be super duper complicated. It's really meant to actually promote, some systematic and consistent revision, basically, right? Because the material is new, so I just want to make sure everyone is keeping up to date and current with the what we're covering. So I put an asterisk over here. By the way, all of this is inside your lecture slides already. I added on this bit here though, by the way. So please take this now, these two here. But again, I'll put it up on Canvas. So for the MCQ, right, we're going to use these bubble forms. So these are the forms with the little circles. Then you just shade in your correct answer, so we can we just scan it and then we get the results fast. So because you're using bubble forms, right, I need you to remember to do two things. I will remind you again. One of them is bring a 2B pencil, right? Because it needs the lit content. And the other thing is your metric card. And the reason is because for these forms, right, your identification is basically going to be a metric number. So very important to bring a metric card. but maybe more important to ensure that you're shading in the correct metric number. Otherwise, there's no way of tracking whose paper is whose. And that obviously is not great, right? Because if you shade in the wrong number and then we can't tell who you are, basically you end up with no marks, right? So please make sure to do this. So take note of this info. I'll of course send a reminder email closer to time. So the coverage. So basically it will cover everything in the lecture, everything in the tutorials, and the textbooks. I put the chapters up here. All the way, basically, it's all the stuff that's up to today, right? All the lecture materials up to this week, and all the tutorial readings up to this week as well. So the long-term memory tutorial will not be this week. It'll be we'll push it back a couple of weeks actually. So it's just up to today's lecture, but of course the tutorial, the short-term memory stuff and the attention stuff can be covered. So that's the coverage of the test. Like I said, it's not going to be super duper complicated or anything like that. It's really meant to make sure that people are studying consistently and they're not, that you're keeping pace with the course. So please make sure to study, before the test, obviously. That's kind of it from me. So I'm of course happy to have to take questions. Yeah. Oh, there is something in the chat. Hold on, let me just get to that. Okay. Oh no, it's a direct message. Can you maybe just email me this? Well, I'll take some questions that have to do with the course now. The other stuff maybe we can take it offline. Any questions about the material today? I'm happy to take any questions as usual. Anybody? Okay, going once.
Hi,
Oh,
Prof.
yes. Okay, yes.
Okay, I have a question about the Hyde-Jenkins experiment.
Sure.
It's about the graph. I think there was a graph with the E number of letters, pleasant and memorized.
Yep.
I was just wondering, this is more about the design of the experiment, I guess you could say. It's like you mentioned that in the pleasant one they weren't told to they weren't told the same things as in the memorized group, in which the memorized group was like they were told to do whatever they wanted in order to memorize.
Yep.
But the pleasant one and everything before that also wasn't. Then I think you mentioned you drew the connection that the group of the memorized ones also drew some deep association with the words, like just how they did in the pleasant group. But I was wondering if there's like more of a correlation thing than like causation, because you can't really tell what the memorized group did.
Yeah. No, you're absolutely correct about this. It's more like it's a conceptual relationship, right? It's not that they actually tested this thing. But I think the point is that, if the point, I think from the perspective of Hyde-Jenkins, or at least depth of processing experiments, right, is that if they were all equally good, right, then it doesn't really matter. The depth of processing probably is irrelevant. But I think what they're showing is that depth of processing does play a role. You don't have to link maybe, for example, the pleasant to the memorization part. I guess you could, the truth is you could actually do this experiment without the intentional memorization. And the point is that the pleasant versus the shallow processing. So shallow processing will be the E and number of letters, that kind of thing. You do get different performance. No, excellent point, Joel. Yeah, it's not necessary. I was just tying this in to show that actually the patterns are similar for deep processing and what people normally do. So it's not that, I guess technically speaking, it's not that people are always engaging in shallow processing, right? It looks more similar to the deep processing pattern. No, it's a good point you raised. It's not, the experiment did not test this directly. Yeah, I'm just making the conceptual link. Separately. Yeah.
Okay.
Thank you very much. Thank you.
Thank you.
Okay, I got some questions in the chat. So can our language capabilities affect the type of memory we have? We remember something, but we don't know what words used to describe it, but we can remember the actions taken. Interesting question. Brian, any chance you could maybe give us a bit more of a flavor, like what kind of thing are you thinking of? Maybe I give you what I think is my interpretation of this, then you tell me whether I'm right or not, okay? So are you saying something like I may have experienced a particular thing, uh, an episode, but I may not have the linguistic ability to describe the episode? Is it something like that? Okay. Um, okay, so the truth is that it is declarative memories, like I said, explicit memories that are not technically tied to specific testing modalities not testing paradigms, right? So if you can't describe the thing, there are other ways, right? I mean, you could ask the person, hey, look, can you try and tell me what you saw, what you experienced? Now, if they can't recall, you might try other things, right? You could say, is it similar to this particular kind of scenario, or can you draw it out, or can you recognize it? Things like that, right? I mean, if you ask someone to describe a face of a person they've seen previously, I mean, not everyone has like the language to describe a face um really well. I mean, you might say, okay, I got eyes, nose, mouth, and all that, right? But then the nuanced information might be very difficult, right? Can't think of like a really good way of describing a person's face exactly, right? Just using words. So it's not actually tied, it's not tied to it. But of course, language is important in the sense that it is one way in which we declare something, but we can do other things. We can point, right? That would be a declarative memory. We can draw something out. We can recognize something. So you don't have to say anything. You just say, yeah, that's what I saw, or not, right? Does that answer the question, Ryan? Okay. So got a question from Moses. Does procedural memory mainly involve only motor functions and not semantic procedures? Um, and I think there's a follow-up. So is memory processing mostly intuitive and habituated, such as inclining towards rehearsal when we are okay, so slightly different. Um, okay, so does it involve only motor functions? Uh, at a basic course like this, probably, or you'd probably say yes. But the truth is, answer is no. So it turns out that procedural memory can be any type of procedure. And most of the time we talk about motor procedures, learning to ride a bicycle, doing the mirror drawing thing, maze tests and stuff like that. But the truth is, procedures are basically kind of like habits, right? Learned skills, learned habits. And a habit can be both motor in nature, but it could also be cognitive. So there may be certain types of tasks, when we see them, we immediately do them. We may not know why we come up with a solution, but it's a kind of cognitive habit. And to preface your, or maybe just to answer a question which you didn't ask, in which case does that mean that if I've got damage to the procedural memory areas, will I see deficits to both motor habits as well as cognitive habits? Answer is yes. So there'll be certain parts of the brain that relate to the learning of these procedures. And if you damage them, then motor procedures, but cognitive procedures as well might be affected. And these are the ones that it's like a cognitive habit. You see it, immediately do it mentally, right? Something mentally. Does that answer that part of your question, Moses? Okay, slightly longer question from is memory processing such as inclining yes, I guess to some extent. So I'm guessing your question is something like this. It's almost like the use of auditory codes, right? So if you have an auditory code, then there's a tendency to use it, right? And I think it's a little bit like that. I think for certain things we try and rehearse them often, but I think for certain things, depending on the material and the circumstances, we know how to switch and do like deeper processing and things like that. Um, Might consciously choosing and being aware of extracting and processing memory be a better way to reinforce memory? Might that type? Yeah, certainly. I think if you do know, if you've got some, I think over time we learn certain memorization techniques that work for us and that we're comfortable with using over and over again. And and then we fall into this habit of using it, right? Or it's maybe I used the word habit here wrongly, but we fall into this pattern where we use it as and when. So for example, if I mean, you could be the sort that just deep processes practically everything. I give you a grocery list to remember, right? You'll try and figure out what it is that the person is trying to make, and then from there, this will help you with your memory of the thing. So yeah, I think there are certain mnemonic techniques that people use, and these can be quite helpful. Um, Above and beyond, some of the things that we've discussed today. Yeah. Hey, any other questions? Okay. Well, okay. If there are no other questions, then thanks very much for coming, everyone. I will have a nice break next week, and then of course, please don't forget to study. And then I'll see you a couple of weeks time for the test. Okay. See you all, everyone. Thank you. Bye bye. Thanks for coming, everybody. See you all.